Back in August of 2017, I keep talking about this. It was actually one of the great moments of my life because that solar eclipse that came through in August of 2017, I first heard about it when I was a sophomore, maybe a freshman at Young Harris College, which is a tiny college up in the North Georgia mountains. And spent my freshman and sophomore years there. And my astronomy professor, this is back in 1987, so it was my sophomore year. 1987, my professor said, yes, in 2017, 30 years from now, there's going to be an eclipse coming through, and the shadow of the moon is going to fall right over our little college here. And we all laughed. Do you know why? Because in 1987, 2017 didn't even sound like a year. It's like so far off. It just didn't even sound like a year to us. It was something out of science fiction, you know. So we all, ha ha, so funny. But it turns out that I ended up back on that same college campus 30 years later, and I saw this eclipse. And it was one of the high moments of my life. I've never seen a total solar eclipse. And if you're not careful, you could go through your whole life and not see a total solar eclipse. I don't mean a partial one like you had in Atlanta here. I mean a total one. And I'll tell you what I mean by total one with one of these pictures here. We're going to talk about solar eclipses here in video 12. And just like there's 3 kinds of lunar eclipse, there's 3 kinds of solar eclipse. And the first one is the total solar eclipse, the king daddy of solar eclipses, of all eclipses actually. So what we have here is the sun. Again, you recognize the sun anywhere. We have here the moon. Okay, we're talking about the moon shadow here, not the Earth's shadow. And so if the moon, when the moon becomes new and falls between the Earth and the sun, if the alignment is perfect, and as we'll see, if the moon is close enough to the Earth, then what can happen, this is the Earth. I'm not going to use blue for the Earth. I've been using blue, but the blue's getting weak. I'm going to use orange for the Earth. This is the Earth. So the Earth is right here. Notice that the umbra of the moon just barely touches the Earth. Okay, it doesn't go into the Earth, so that shouldn't be there like that. But the umbra of the moon, if you imagine the Earth like, you know, just like a ball, a beach ball or something, and just taking a pencil and just running the front of the pencil across the beach ball, that's what the moon's umbra does to the Earth during an eclipse. It just rakes across it. The tip of it barely touches the Earth. The actual moon's umbra is much more stretched out than this. This is, I sort of fattened it just to make the drawings fit. But as the moon passes in front of the sun, the tip of the umbra just scrapes the Earth. So there's a little bitty spot on the Earth where the moon, where you're actually inside the moon's umbra. Okay, and if you happen to be at that point on the Earth, then what you see is a total solar eclipse. So this situation here is the total solar eclipse. The first situation is a total solar eclipse. Okay, I got some numbers here. The total solar eclipse, number 1. Remember the moon, the lunar eclipse lasts a couple of hours. The total solar eclipse lasts a maximum of about 7 minutes, maybe 7.5 minutes. That's it. Okay. So number 1, the total solar eclipse, actually let me do it this way. Total solar eclipse lasts a maximum of 7 minutes. And you have to be at that point on Earth, right there where the umbra, boom, touches the Earth. That's where you have to be in order to see it. If you're anywhere else on Earth, here or there, you'll see a partial solar eclipse. Talk about that next. Okay. So right there, where's my blue? Where'd my blue go? There it is. Right there, actually I want to make a yellow spot here. Right there, that yellow spot, you can see that? That yellow spot there, well, it doesn't show up that well. Right there is where you see a total solar eclipse. Out here, you see a partial. But right there at the spot, you see a total solar eclipse on that one spot. So you have to be at a particular point on Earth. And even then, it only lasts 7 minutes. So the shadow of the moon, the umbra of the moon, sweeps across the planet, travels about, the umbra moves about 1,000 miles per hour across the face of the Earth. Pretty fast. And it's about, the umbra is about, on the average, something like, is it 100, let's see, 150 miles wide. So there's a circular shadow, 150 miles wide, moving 1,000 miles per hour across the face of the planet. And back in 2017, that shadow moved from, in the northeast, from, Washington State, Oregon, all the way down through South Carolina, moving 1,000 miles per hour. So you had to be at the right place at the right time. Okay. They also occur, about once every 18 months. So they are just as common as total lunar eclipses. Okay? But the difference between a total solar eclipse and a total lunar eclipse is that you won't see the total solar eclipse unless you happen to be right there at the right place at the right time on the planet. Unlike a lunar eclipse, not everybody on the planet can see the total solar eclipse. Okay, you have to be along a path, a very narrow path, a 100-mile wide path somewhere on the planet in order to see the total solar eclipse. So somewhere on the planet, you get a total solar eclipse every 18 months. But any given point on the planet, say the city of Atlanta, how long do we in the city of Atlanta have to wait, on average, for a total solar eclipse to come across the city of Atlanta? Turns out we have to wait about 400 years. If we don't want to go anywhere, if you just want to go out and find some random spot on the Earth and stand there, you're going to have to wait on the average about 400 years for a total solar eclipse to come to you. So what you do is you go to them. That's why I drove with my kids and the family up to North Georgia to see the total solar eclipse. Okay? It was awesome. But I guess you get that idea by now. Okay? Yeah, about 400 years. So you can see a partial solar eclipse in this case if you're anywhere else on the Earth but in the path of totality, it's called. Okay? The path of totality. That is the path along which, if you're on that path, you'll see the total solar eclipse. And totality is the event when the Earth is totally, when the sun is totally blocked by the moon. So what you see in a total solar eclipse is you just see the dark side of the moon. And you see a halo of light around it. But the sun's face is completely blocked. Okay, so I'm going to actually make that blue. Okay, so what you see in this case is just the back of the moon, the dark part of the moon. And then you see what's known as the halo of the sun sort of shining around it. But it's quite dim, and the sky goes dark. The birds go a little bit bonkers because they don't know what's going on. The crickets start chirping, stars come out, it gets dusky. It's really quite an experience. You know, at 2 o'clock in the afternoon on a perfectly clear day. The other way you can get a partial eclipse is if the moon's shadow, if the Earth misses the umbra and passes into the penumbra. This is a partial. Second situation here is a partial solar eclipse. And in that case, what you see is you see the back of the moon, but you see part of the sun too. Okay, so I see the face of the sun like that. But it's got a bite taken out of it by the moon. That's what you see in a partial solar eclipse. You can get a partial eclipse either in a situation like this where the moon's umbra misses the Earth altogether, or in a case like this where there's a total eclipse happening, but you don't happen to be in the path of totality. Okay. The third one here occurs when the moon, now I'll draw it over here. The moon's orbit is not circular. So if here's the Earth, the orbit of the moon is elliptical. So sometimes the moon is far away, and sometimes it's close up, right, as it goes around. So that's the Earth in the middle. Moon goes around it. Sometimes the moon is close, sometimes the moon is far away. If the moon is too far away, then the umbra is not long enough then the Earth and the moon are too far apart for the umbra to make it to the Earth. So nowhere on Earth do you get a total solar eclipse, because the umbra comes to a point several hundred miles above the Earth's surface. And this is the case, again, when the moon is far from the Earth. So it looks smaller, so it doesn't cover the whole sun. Okay, it doesn't cover the whole sun, it just covers the central part of it. In this case, you get something that's a little unusual, known as an annular, not annual, but annular solar eclipse. Annular as in ring. Okay, so in that case, what you get is you get the back of the moon, and around it you can see the edge of the sun. So the sun's outer part makes a ring around the moon, and so you get a nice, bright, brilliant ring. Okay, you don't get the whole dusk effect, you don't get all the cool effects you get with totality of a total solar eclipse, but you do get a pretty cool effect. And the moon appears, again, it appears small because it's far away. It's not big enough to cover up the whole sun, and so the outer edge of the sun is visible around the moon, and in that case you get an annular solar eclipse. Okay, those are the three kinds of solar eclipses: total, which is the queen mama of all of them; partial; and annular. All right, I think that's it. See you next video.